Base 2 of 2. What do? We can punch this into our calculator by going log 2 divided by log 2. Because remember, if we had it like this, we could always draw a line and we could punch it in like this if we didn't have the log base function. Or we can use our brains and we could say 2 to the what is 2? 1. 2 to the what is 4? 2 to the what is 8? 2 to the what is 4? 16. Whoops, gave the answer. 4. 2 to the what is 32? 2 to the what is 64? 2 to the what is 128? That's not 8. Who said 8? 7, 8.
Why did they do that?
Proof.
Why would they make it so easy? You can get the first 3 and then just keep going. Like, if you get 1, 2, 3, it's going to go 4, 5, 6, 7, 8.
Enjoy. Okay. Shh. Now let's look at this. We're going to see if this rule is true. Paying attention, please. So if we have this written like this, correct? Log base 2 of 4, log base 2 of 8. Do you see that they both have base 2?
Yes.
That's important. So log base 2 of 4 is 2. Log base 2 of 8 is 3. 2 plus 3 is? Okay. Now, people want to write this as a single logarithm. And what they do is they go log base 2 of 4 plus 8, because it has a plus sign. That would be log base 2 of 12. 2 to the what is 12? A decimal of some sort, right? Is that 5? No. So the laws of logs, and this only works if you have a plus 1 in front of the log. It's up here. It's called the multiplication rule. It's right here. Well, that's not your work formula sheet. That's right here on you guys. Do you see here there's a 1 in front of the logs? There's also a 1 in front of this log. They have to have 1s in front. If they have a number in front, we have to do something else. So if they have a 1 in front and they have the same base, you can put them together by multiplication. So you're going to go log base 2 of 4 times 8, which is log base 2 of 32. What's log base 2 of 32 above? 2 to the what is 32? That's why we had these up here. It's 5. And it matches the same as if I just did them separately, right? Now, people say, well, why can't I just do them separately? Because they're going to have variables, not have numbers, and then you can't even find the math of them, right? But they'll ask you to put them together. So you can only put together logs with an addition sign if they have the same base and a 1 in front. We're going to write that down as a little side note. You can only combine logs by addition if each log has a coefficient of +1 and the bases are the same. That'll come. You can have a -1, but it won't be addition, it would be subtraction, right? Because a -1's like a subtraction sign in front. By chance of the fact that you guys are smart, what would you do instead of multiplying? You would. So we're going to go through this quickly because I like when we can put all the laws together, because they're never going to give you something that nice. So let's look at this one. So this is our lovely rule. It works in both directions. Now, please pay attention. Everyone will spot this. They'll spot when it has the same base and an addition. They'll spot to put it together as a multiplication. What you're not going to spot is when you have something together as a multiplication, you can separate it. So if I had, say, log A, like this, say I had it like this, log base A of AB, most people don't spot that that could actually be rewritten as, or it's equal to, I don't know why I put an arrow, equal to log base A of A plus log base A of B. And what's log base A of A? 1. So your answer on the diploma is 1 plus log base a of b. But you don't even spot right off the bat that you can make these separated. Everyone's really good at putting them together. They forget that you can put them apart. Okay, do you see how that's an issue? So this one here is log base 2 of 15 plus log base 2 of y. They both have plus 1s in front of the logs. So it's going to be log base 2 of 15y. Because it'd be 15 times y, which is 15y. Okay? So you get how everyone spots them putting together. Instantly when they have the same base, there's a good chance they're going to get you to put them together. Okay? And that's easy to spot, but separating them is something that everyone forgets. Okay? So this one we're going to expand. Log base 3, 9xy. What everyone realizes is they can separate the 9x and the y, so they'll go log base 3 of 9x plus log base 3 of y. But the 9 is actually multiplied by the x is actually multiplied by the y. So how many terms will we get? 3. You could do just 2, but 3 is better, and you'll see why. So we're going to get log base 3 of 9 plus log base 3 of x plus log base 3 of y. Yeah. So what do we do here when it's log base 3 of 9? What's that? 3 to the 2. 3 to the what is 9? 2. So we actually get 2 plus log base 3x plus log base 3y. Same rule works with subtraction, just that you divide. Now, this is the thing. I don't mind teaching the rule like this. It's the way that everyone gets taught it. But there's going to be a point where you're going to have plus and minuses mixed. Okay, it's never going to be just all plus and all minus. Most of the time there's some additions and some subtractions. The key thing that I need you to know is whenever there's a plus 1 in front, it would stay on the top of the fraction. Okay? When there's a minus 1 in front of it, that number goes to the bottom. Okay? So plus 1 in front, number goes to the top, goes to the numerator. Number, or I guess variable, I shouldn't just say number, goes to the numerator. Negative 1 in front, number goes to denominator. So then we can go back up here for a second once that's written. All right, so we have 2 to the 8 is 3, right? 2 to the what? Sorry, 2 to the what is 8, 3. 2 to the what is 4, 2. 3 minus 2 is 1. If we put them together, they have the same base. So we're going to go log base 2. Anything with a plus 1 in front goes to the top. Anything with a minus 1 in front goes to the bottom. So we have a plus 1 in front of the 8, so it goes to the top. We have a minus 1 in front of the log here, so the 4 goes to the bottom. So it's going to be log base 2 of 2, which is 1. Same answer. What happens if you had 2 with negatives in front and none with positives in front? They're both on the bottom, and what's on the top? 1. Okay? So you try these two. So for this one, you're going to get log base 2. And because there's a plus 1 in front of the 15 goes in the numerator. And because there's a negative 1 in front of the y goes to the denominator, and that's as good as it gets. This one you can expand out. It would be log base 3 of 9 minus, because the x is on the bottom, log base 3 of x, which would be 2 minus log base 3 of x. Okay? So I'm going to show you how the power rule actually works, because people don't get why the power rule works. They just trust me. But I want you to know why it actually works. So there's a rule on there. It's called the power rule. It's the third formula in the laws of logs on your formula sheet that states that I can take this exponent if it's just here and I can bring it in front of the log, or I can bring it up, if it's in front of the log, I can bring it up to the exponent. Okay? This is why. So log base 3 of 2 to the 5, 2 to the exponent 5 just means 2 times 2 times 2 times 2 times 2, right? So I can write that out. I can go log base 3 of 2 times 2 times 2 times 2 times 2. I can write it out long like this instead of with the 5, correct? Now, if I have multiplication, I could also write those out as additions, right? We just went over the rule that if you multiply things, you can separate them by addition. So I can rewrite this as log base 3 of 2 plus log base 3 of 2 with the plus 1s in front, correct? How many log base 3 of 2s are there? 5. So you could write this as 5 log base 3 of 2, could you not? So that's the reason why this 5 can just come in front of the log, or it can go up as the exponent conversely, because you have 5 of them. Okay? It works in both directions. So why is this a good rule to know? The only way I can put stuff together by addition and subtraction is if it has a plus 1 or a minus 1 in front of it, correct? So now we know that if it just has a coefficient in front of it that's not 1 or negative 1, I take that coefficient and I bring it up to the exponent, and then I can do it, right? Just one little extra step. Now everyone forgets to do that. If you forget to do that and you do some crazy math with the front of those things and put them together, that answer will be on your diploma, because that's going to be the common error, right? All right. So this log base 3 of 9 squared can be written as 2 log base 3 of 9. And then that can be simplified. It's going to be 2. This 2 is being multiplied by the log base 3 of 9, right? So that would be 2 times, what's log base 3 of 9 equal to? 2. So it's actually equal to 4. Now this one, k log base 2 of a, I can write as log base 2 of a to the k. And we need to remember those rules. We need to know that the exponent in the front can come up, or the coefficient in the front can come up as the exponent, or the exponent can come down as the coefficient. Yeah. This one here, people don't spot as an exponent. They see a radical and they start crying a little bit. Remember, 27, the square root of 27 is 27 to the what? 1/2. Because it's just the square root of 27 to the 1, technically, right? And I can take that index of 2 and I can drop it underneath and it becomes a half. Remember when I did this? It was like this, the square root of 27, when it doesn't have an index, it's a 2. What exponent is this 2 if it doesn't have an exponent? 1. And then how do we write the exponent? We just draw a line and we bring the index underneath. So it's the same as 27 to the half, right? So this is log base 3 of 27 to the half. Now people will say, well, I can just simplify that. No, I took away your calculator. What's the square root of 27? There is no square root of 27. There's a cube root of 27, but there's not a square root. Okay? But I can simplify this by just doing my math. I take that half and I drop it in front, because I do know what log base 3 of 27 is. I just don't know what log base 3 of 27 to the half is. So I drop the half in front and I get rid of that half issue sitting in front, and then I have log base 3 of 27. Right? Now, log base 3 of 27, what's that? 3 to the what is 27? 3. So I have a half times 3. I didn't touch my calculator because I don't need it. I ain't got time for that. I ain't got time for that. Time constraints. Don't use it. And the reason why you don't want to use your calculator is, in this case, you could have used your calculator, but do you think they're going to give you something that you could directly punch into your calculator? No, they're going to give you a variable in there somewhere. So you actually have to know the math in order to do it. So, okay. So what they might do is they might go like log 3, and I guess you could do the 27 to the a, and then it would be a over 2, and you have to do math like that. That'd be completely fair if they did that. Instead, they could go like this. Log base 3. They could do it in, like this if they wanted to. Which would be log base 3 of 27a to the half. Drop the half in front. Log base 3 of 27 and a. And what could I do with these two? You could add them. But can you add them like this, though? No, people want to add them like this. You can't. Why can't you? There's a half in front of the log. You can only separate them if there's a 1. So instead of bringing the half in the front, which is what I did just to trick you, what would you have to do with that half? You'd have to put it to the 27 and put it to the a, and then you could only separate them. So this is why you need to know your log rules well. You can only separate addition and subtraction, like you can only separate to addition and subtraction from multiplication and division if there is a positive 1 in front of the log. There has to be a positive 1 in order to do it. And if you don't remember that, look at your formula. Your formula doesn't have a variable in front of this log here that says it could be something else. It has a 1 here. So if it has a 1 here, this rule only works if this has a 1 here. Okay? It doesn't have an A or a B in front of that log. It has to have a 1. So the only way, if I wanted to expand this out, the only way I could do it is take the exponent up and then distribute it to the 27 and to the a to the half and then separate them by addition. That's the only way. Okay? All right. So this question here, they're both base 2, so we're happy. But what's our issue? There's coefficients, there's numbers in front. You can't put them together if there's numbers in front. You can have a +1 in front or a -1 in front. So what am I going to do with this half or this third? Just bring it up as the, bring it up as the exponent. So we're going to go here, and we're going to get rid of them. Now, with these exponents, it's actually awesome. Because what's 16 to the half, actually? Just the square root of 16, which is 4. So we have log base 2 of 4 minus, and then what's, this would be the cube root of 8. What's the cube root of 8? 2. Could I just go ahead and do the math right now? Yeah. Could I put them together? Yeah. Is either way more better? Is it either way more better? This is some good English. Is either way better? No. I'm going to put them together just to prove a point, but I would have probably just done the math. So it'd be base 2, 4 divided by 2. So it's log base 2 of 2, which is 1. If you did just the math, 2 to the what is 4? 2. 2 to the 2 is 1. 2 minus 1 is 1. Either way, you get 1. Are they going to give you questions where it's probably all numbers? No. Probably going to have variables. So I want you guys to try 3 and 4, please. See if you can do them. So the only thing we have to do first is move that 2, that's a coefficient in front of the log base 2 of x, up as the exponent. Then anything with a +1 in front stays on the top in the numerator. Anything with a -1 in front moves to the bottom, to the denominator. So we're going to get log base 2. And on the top, we're going to get an x. And we're going to get a 2x. We're going to get an x squared on the bottom and a y. Now, when I have more than one thing together, when I didn't have subtraction signs and I just had addition signs, what did I do with those two things? I multiplied them. That's all I'm going to do. If there's more than one thing on the top or more than one thing on the bottom, I'm going to multiply them. Okay? So it's going to be like this. So I get log base 2 of 2x squared over x squared y. The x squareds cancel. And it's log base 2 y. Now, that answer is not on the diploma. It's a good answer, but it's not there. I instantly, yep, really good at speaking today. I instantly saw there's two 2's there. So there's a base of 2 and there's an actual 2. What you need to realize is with logs is sometimes you're going to put them together in order to cancel some stuff off, in order to pull them back apart to get the answer that's there. So this I could separate as log base 2 to the 2 minus log base 2 y, and 2 to the 2 is 1, so it's 1 minus log base 2 of y. And that's the answer on the diploma. This is a good answer. I like it. It's really nice. It's just not there. That's the hardest part of logs on the diploma, is not that you don't know what you're doing. Often you do. It's just you get stuck in one spot, or you just can't seem to get the answer. So you need to know your laws really well, and the best way to do that is practice. Because practice, you'll say, hey, oh my goodness, they're the same number. I should probably separate them because I know that they'll cancel or do something like that. Or if this is a 4 or an 8 or a 16, those are levels of 2, right? And then this one here is log base 2. I'm going to do it actually together, because if I try and do the math, 2 to the what is 3 or 2 to the what is 6, nothing, right? So I'm going to put them together and see if that makes it any better. 1 in front, so the 2 stays on the top. 1 in front, so the 3 stays on the top. Negative 1 in front, so 6 goes to the bottom. Negative 1 in front, so 8 goes to the bottom. So I get log base 2 of 6 over 48, which is log base 2 of 1 over 8. Now you can separate that out, or 1 over 8 is 8 to the what? Negative 1. So you can get log base 2 of 8 to the negative 1. 2 to the what will get you this. You can, honestly, I always just go 2 to the what gets me 8. So 2 to the what gets me 1/8. Negative 3. If you do it like this, this works, but you can't go 2 to the 8 gets me what and then have a negative 1 up here. You can't do that. You would have to bring the negative 1 in front. Negative 1 log 2 to the 8. And then you would get negative 1 times 3, which is negative 3. You can't go 2 to the what if this isn't together. You can only go 2 to the what gets you that number if that number is a whole number by itself. 8 to the negative 1 has an exponent, so I have to take that negative 1, I have to drop it in front. Okay? So you're going to do these examples on the next page. These ones here. If you don't have this printed off, I will leave it up here and you can scroll. And this is your homework. So you're going to do all of the questions for practice as well from these examples. You're going to do these all down. These we will mark tomorrow in class. So number 1 all the way to here, including this one, we will mark tomorrow in class. And then that's your assignment. So that'll be your little quiz from 1 to 7.